down. So today is Thursday, September 10th, 2020, and this is MUS 349 and GMUS 544, and we're looking at the Logic Pro environment window. And I need to size something else that's off your screen so I can see what I'm doing. So give me a moment. There we go. Okay, glorious. Okay, so I happen to have in my paste buffer an object that does something interesting. So I'm going to paste it in. There it is. And now I'm going to connect it. So this is that classical guitar same file that I dropped off for you in the common file stream folder that's in our class folder. So now I'm going to connect, well, I got too many there. I have to get the top one. There we go. Okay, so I have now connected the sum from the physical input, which is a fancy way of saying my connected MIDI controller, through the velocity limiter that peels off velocities above 111, or actually above 110, it peels off the velocities. I could make that a different number. There we go. I forgot that was off screen for you. Here we go. So that's what this limiter is doing. It's actually not even going all the way up to 123. You know what? I think I'll put it back to 123. So I'm just going to double click here, 123. And so if it's greater than or equal to 123, now it's going to be 123. So now I cannot play a velocity higher than 123. And then it's cabled to this gadget. And look what it says. It says C1 to E1, notes to pitch bend. Well, as it happens, C1 is the lowest C on a 5-octave keyboard. This is middle C. And here, I'll make this look like a 5-octave keyboard if I can grab the end of that and stretch it. I guess I have to click it here. There we go. So in order to make that little box visible so I can grab it and stretch with it, I have to first select the object by clicking the name. Then I can grab that little box and drag over. Okay, so this is now looking more or less like a 5-octave keyboard. Here's middle C, C3. I have 3 octaves above it and 2 octaves below it. So C1 then is this lowest C on that 5-octave keyboard. And so this environment object is going to intercept notes from C1 to E1 and turn them into pitch bend messages. And the way it works is D, when I hit the note D, it means no pitch bend. And here's the proof of that. I'm going to hit the note D on my keyboard. And in fact, I'm going to get my little on-screen keyboard up so you can see what I'm doing. Okay, so this is my 5-octave on-screen keyboard, and this is middle C. See it? Okay, so now I'm going to hit D, and when I hit D on my 5-octave keyboard that I'm using here as a controller, actually, well, I'm using 5 octaves of an 88-key keyboard at this moment, but who's counting? So notice what happens when I hit D. Look at the monitor here when I hit D. Do you see that it generated a pitch bend message of 2 data bytes, 0 and 64? Is that making sense to you? And then when I released the note, of course, it generated a D note off. Well, since the note D wasn't ever turned on, nothing happened. Now look what happens when I hit C sharp. It generates a pitch bend message of 032. And when I hit C, it generates a pitch bend message of 00. I'm going to hit D again, and now we're back to no pitch bend, 064. Now I'm going to hit D sharp, and I have a pitch bend message of 096. And finally, I'm going to hit E, and I have a pitch bend message of 127, 127. And in each case, the note offs just don't do anything. They get generated when I release the note, but they have no function. They cause no change in anything because no note was turned on of that pitch. So here's how you can use this then. And so I'm going to hit this G, that one, And I'm just going to play a little mordant. So did you see what I did? I hit the G, and at the same time I hit these notes down here. Are we getting the idea there? And here's, and so you can see I can even do kind of a, or a, just by hitting these half steps down here in this zone at the same time as I strike that note. I could even play this note and then do these things as overdubs, right? Just overdub into the track later after having first just played this note G. So this is basically converting then, this object is converting notes in the range from C1 to E1 into discrete pitch bend messages. So let's look at what those pitch bend messages are. 0, 0 is clearly all the way down, right? When I hit C, 0, I'm going to refresh that monitor. I'm going to make it a little bit bigger so it's easier to see what's going on here. There we go. Okay, so when I hit D, I have 064, and of course you're supposed to have learned by now that that means no pitch bend, and we have a fancy name for the 64 data byte. Does anybody remember what our fancy name is for the 64, the second data byte of a pitch bend message? It is the most significant byte. Remember that? MSB, most significant byte. That's all in that document that I put on binary and MIDI data types in the common file stream. So in pitch bend messages, the first data byte honestly has very little effect because all it does is identify 128 possible little hash marks between, let's say, 64 and 65. Or between 65 and 66 for the second data byte, there are 128 hash marks from 0 to 127 that are in the first data byte. So that's why this is, you could think of the second data byte as minutes, and you could think of the first data byte as seconds, or something in that way of thinking. That they both have a possible range of 0 to 127, but the seconds just define positions between minutes. And in that sense, the first data byte just defines positions between adjacent values of the second data byte. I hope I said the first data byte. I'm not sure what I said. I'll say it again. The first data byte defines positions, 128 of them, numbered 0 to 127, between adjacent positions of the second data byte. So 64 to 65 will have 128 positions in between it, or 65 to 66, same thing. So no pitch bend is 064 because 64 is more or less halfway between 0 and 127. So when you have 127 here as the first data byte, and you have 127 here as the second data byte, that is the highest possible pitch bend message. And so that's very close to simply being 0, 128, isn't it? It's like we're saying, it's not really 11 o'clock, it's 10:59 and 59 seconds. It's as if we're saying it that way. So 127 means something like that. It's almost 0, 128. But why can't we have just a 128 here? Does anybody remember? Had to do with the way binary data works.
Because a data byte can't go over 127.
That's exactly right. And that's because data bytes always have a 0 for their leftmost bit. So even if all the other 7 bits are set to 1, so that the binary number is 0, 1, 1, 1, 1, 1, 1, 1, even if it's that way, the highest value that can be is 127. And in fact, that byte 0, 1, 1, 1, 1, 1, 1, 1 is exactly 127 decimal. So with all that in mind then, that's why we can't have 0, 128, but you may as well think of this as 0, 128 if that helps you understand that 064 is exactly in the middle of the possible pitch bend range. And then when I hit low C, we have, well, it didn't seem to happen there. Let's try it again. There we go. When I hit low C, we have 0, 0 for the pitch bend message. And that's, of course, as low as the pitch bend can go. So there's a couple of things to keep in mind here. One of them is that the pitch bend itself, the pitch bend message, does not actually define how far the pitch can be bent. That is set up in the synthesizer itself. I'm going to close this for a moment. And the place that is done in these synthesizers is not visible until you turn off some things. So in this case, I had to turn off these two buttons in order to see all the details just of the oscillator section over here. And now I can see the pitch bend message here can be up to or down, and I'm going to say down to instead of linked. Okay, so now the pitch can be bent up to or it can be bent down to. Linked sometimes produces that same, well, it basically produces the same effect as setting them to be the same. But here's an interesting thing you can do. I can do, well, I'm trying to make the pitch bend message be something different. There we go. So now I'm saying the pitch bend can be bent down 4 half steps, but only up 2 half steps. See that? Let's see what happens then when I hit my notes. So I'm going to hit G. So I just hit the note D1. Let me get my little on-screen keyboard back. It'll help you to understand what I'm doing. And it's back. And now I have to open this up again. Okay. Every time I click on it, it disappears. So here, let's get it back. All right. So you can see that I'm playing the note G, and when I hit D, I have no pitch bend. But remember before when I went down to C sharp, that low C sharp, that one, it went down a half step, remember? What do you think it's going to do this time? When I hit the G up above and go down to the low C sharp in my left hand. Any guesses?
Another half step?
Actually, yes, it's going to be another half step. So it's going to be two half steps, in other words. So it's going to be a whole step. So I'm going to hit D and go to C sharp. And now when I hit G, you hear it's a whole step down. And now when I hit C, it's going to be another whole step down. Okay? And that behavior is happening because we've now made the lower pitch bend range 4 half steps instead of just 2 half steps. So are we understanding that the exact numbers in the pitch bend message itself don't determine the exact amount of pitch bend in terms of what you hear? What you hear is a combination of two things: the pitch bend range that has been set in the synthesizer, and then what proportion of the pitch bend range is identified by the pitch bend message itself. So it's the two things have to be true. So what's most common is just to have the pitch bend range set to be, boy, it just won't go back to linked here. It says 4 there. I wonder if I can make it redraw itself. There, I went away and made it redraw itself. It's like there's a screen redraw bug there, and it didn't want to acknowledge that I had reset it to linked, but it's set. So this is the most common situation where the pitch bend range is the same up and down. And so if you're just using the pitch bend wheel itself, then when you bend the pitch up, the highest it can go is this many half steps above no pitch bend. And it's also, when you bend the pitch bend wheel down, the lowest it can go is this many half steps below no pitch bend. But again, you can change that behavior by having a different number for up than down. So I've even seen people do funny things like have the down be set to an octave. Look at that, it's not redrawing itself. It's like I have to close it and then reopen it to get it to draw itself. Okay, so now I'm just going to use the pitch bend wheel just to let you hear this. So pitch bend wheel up. see what do you see the little graphical display of the position of the pitch bend wheel here? So pitch bend up, but now listen to pitch bend down. Okay, so that's what you can do if you have a different value for pitch bend down than pitch bend up. I'm going to return this now to linked because that's the most common setting. Hey, what do you know? It actually redrew the screen for once. Thank you. So now it's back to normal. So pitch bend up, pitch bend down. And if I do it with the little on-screen, I'm sorry, with my pitch bend messages on the notes C1 to E1 that I've identified, then I have this. So you can do hammer-ons and pull-offs. You know, this would be a hammer-on, and this would be a pull-off, and so on. Of course, you don't have to use this just for guitar. I'm just using guitar because it was up. But you can do this with any instrument. You could play trills. And some of the trill, you know, it's better to have a true trill sample when you can. But if you need to do a trill and you don't have an actual trill sample that you can select with an articulation, we'll learn how to do that. And you don't want to just play the trill because you hear pluck, 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 pluck. Instead, you can do, and it's a much more realistic sounding trill. It's not perfect, but it's a much more realistic sounding trill than a new attack for each note. Okay, so the question is then, how does this gadget work? So let's take a look. And what I'm going to do right now is just delete this. So you know it exists now, but I'm going to delete it because your assignment is to make it. Okay, so we're going to start making it, and then you're going to figure out the rest of it. So here we go. I'm going to go to the new menu now and create a new transformer. I'm going to drag it down here, and I'm going to cable velocity limiter to it, and then from that to the keyboard. And what we want to do for this one is just have it be a what's the word I'm looking for? A single pitch bend message. A single note is going to get turned into a pitch bend message by the transformer that we are about to make. Just a second here.